So, so who are we? So I'm Paul Appleby. I'm co-founder of Graphologi. We provide knowledge graph tooling. So we have two products, Graphologi and EasyGraph. We're focusing on Graphologi today, and we went over various aspects of Graphologi in the previous demo. It's a service. It's software as a service. You can sign up on that link you can see on screen. You can just go there and give it a trial. And we've got a LinkedIn group as well where you can go and it's a new group where we can discuss it. So after all of this, feel free to go and have a try. It's 2 minutes to sign up. So a brief review of the last demo. In that we covered a few points, mainly around the standards. But the first and most important thing is the idea of identifiers and IRIs. So in a semantic world, this is probably the most important thing you can do is give things identifiers, and in the semantic world that does mean an IRI. Now, some people will call that a URI. They're very similar. IRIs are essentially the internationalized version of a URI. So there's one on screen that you can see there. It's obviously a made-up one, but that is basically the IRI for a concept called programming language. And everything you see in Graphologi essentially has that. That's precisely how RDF works. And then we have the standards that we touched upon, and again, we'll be seeing those in action today. SCOS, which is for taxonomies, SCOS Excel, which is an extension of that, which allows for richer modeling of labels themselves, so the actual labels that concepts have. And then on top of that, we have OWL, which is for modeling your domain as an ontology. So those are absolutely key to a semantic system, and are only present in any system that is basically RDF or semantics. So to build on what we saw from Alex, where essentially he's running the analytics over some content to maybe bootstrap the idea of creating a semantic model and some data to go into some taxonomies. What do you do with that stuff? How does that actually help? So there are various things, and if you think about job descriptions especially, I think they're probably more complex than many other kinds of document because everybody approaches them differently. So, to engage with users and to get better results, you do need to be smart. So, for instance, so what are some of the challenges? Well, in one document, you might see all sorts of variations. You might see abbreviations such as MS for Microsoft or JS for JavaScript. Then there are different ways of calling something. Lots of people use the same synonyms for the same thing. So semantic web, knowledge graphs, and linked data. And there are many examples that you can come up with for synonyms, and we'll show a bit more about that later. And then you've got jobs which might not mention a particular technology. So again, it might mention the XML stack. Well, what does the XML stack mean? And in that respect, it probably means things like XML, XQuery, XSLT. So even if something doesn't mention it directly, you still really want to be able to make that correlation between the two things. And similarly, in another way, grouping technologies together might be very useful. If you see a bunch of XML technologies, for instance, like XML, XSLT mentioned in a document, that probably gives some weight to what that document is about. And so by being smart and making more connections, you might be able to make an assumption that it belongs to something like the XML stack in a more accurate way. And then there's the situation potentially where, say, a person is interested in a particular field. And in the example we've got on screen, it's customer relationship management. Well, obviously, that is applicable to certain companies. So it may be that jobs from certain companies are of more interest to that person than other areas. So there are all sorts of different questions we can ask off the content that simply doing a search on it is not going to give you any answers. And you need to make connections between what the person is doing and what language they're using, what the language of the document might be. So the first thing to do essentially is to model your domain. And what that means for us in this instance is creating an ontology and some taxonomies to supplement your ontology. Many of the properties in your model will take values from a taxonomy, and as we saw earlier, one of those examples might be a programming language. So you'll have a taxonomy of programming languages. So we've got our model, we've got an ontology, we've got some taxonomies. What does that allow us to do? Well, it allows us to start connecting the things together like we suggested earlier. So this is an example of the visualization in Graphologi, and visualizations are great. Certainly when the graph isn't too complicated, they're great at getting across the idea of the relationships between the nodes in that graph. And obviously a graph is made up of nodes and edges. And in an RDF graph and a property graph as well, to be fair, the edges are as important as the nodes themselves. Those relationships have meaning and they're first-class citizens in this world. So we can see that from the example we've got in our graph here, we can answer questions, simple questions in this instance, like find me jobs which mention skills related to the XML stack, because we know that XML is related to the XML stack, or find me IT companies where my XML skills might be useful. And in this instance, well, we know that MarkLogic and XML are complementary to each other, so they're related, and we hold that in our model and in our taxonomies. And so that's a simple example. A slightly more complex example. So in this instance, we've got two steps to get to the answer we want. So the question in this instance is, given I have a particular certification, and obviously if you're a job seeker, there's a good chance you'll have, say, professional certifications, what roles might be suitable for that certification? So you might just have got your shiny new AWS certification or something similar, and you're looking for a new role that to get that big pay rise that you're after. So in this instance, well, we can see that a certificate in risk and information systems control is connected to the area of risk management, and risk management in itself is connected to a role, risk management modeling manager. And those roles themselves may be something that's come from text analysis of a whole set of job descriptions or job titles, so that again you can build potentially a taxonomy from that analysis, and the curation of that analysis to ensure that that the taxonomy is correct. But in this instance, therefore, it allows us to make two hops and answer a slightly more sophisticated question. And there's no real limit to the number of connections you can use to answer questions. The more connections you've got, the more complex questions you can generally answer. So obviously that's the job side of things. We need to say, well, what does a person look like, a user look like in our system? Now, in our ontology, we've modeled a person. We've just got the one example on screen here. It's Mary Smith. So where you manage your entities like people is an interesting question, but for this instance, we've created it in Graphologi. But what it allows us to do and to show is that we can say statements about a person as well. So in this instance, we can see that Mary Smith has a particular certification, has worked for a couple of companies, and has various skills, such as working with MarkLogic Data Hub service. And so we've modeled Mary, and the important thing here is that those relationships and those entities, such as the XML stack, those are the same concepts that we use everywhere else in the system. Everything is connected. So those chips that you see on screen, they have IRIs behind them, and that's how we make all of the connections. Now, another important aspect of many systems is supporting multiple languages, and again, in the world of jobs, this is key, really. There are various considerations. It's very important, really, that your taxonomy application can support multiple languages out of the box. If it can't, obviously this is a non-starter. The standards themselves support it. RDF supports it, Graphologi supports many languages. And if you can do this, then obviously this allows you to do things like search in one language, but find results that are in another language. A job may be posted in English. The job seeker may be searching in French or Russian, whatever language is their local language. And the connections and a multilingual system allows you to make those connections without having to do horrible translations or expect the user to search in languages that they're not that familiar with. So the example we've got on screen here is the idea of the customer relationship management concept, which is that in English, and on right, that's its Dutch equivalent, which I'm not going to attempt to say. But essentially, those are two labels for exactly the same thing, and that's key to the whole semantic sort of graph idea, that it's a single concept that can have many labels, but it is absolutely one thing. And you can see above that in that table, that's a representation of the underlying triples that you would see in Graphologi for this concept. And you can see that there are two pref labels, one in English and one in Dutch there, and various other relationships. And then finally, and very important to the whole thing, is the lifecycle management. So we saw Rover doing some text analysis, and in this particular use case, that might be the first thing you do, and you may well do it later on in the life cycle too. But if we in this instance, let's say we've taken the data from Rover, and we use that to create an initial set of taxonomies, for our roles, maybe for programming languages, and for various other things. It may be geographical locations, that kind of thing. So in Graphologi, you create your taxonomies, and then you use that to essentially bootstrap your application, and do that by integration into your target system. So Graphologi has various means to send data to a target system. So let's say that you've got a system and it's built on top of MarkLogic. So you've got all of your semantic triples have been sent from Graphologi into MarkLogic, and you've got your application built on top of that. And then essentially you're into a BAU, business as usual life cycle. You've got your application up and running, and you're probably getting feedback from users. Is this a useful review? Is this a useful job suggestion? Those kind of metrics coming in from users. So you'll probably take that information, and then with a little bit of processing, you'll actually feed that back into suggestions to your taxonomy, so that perhaps a new programming language has cropped up that you didn't have in your taxonomy, or text analysis didn't pick up, but it's starting to crop up in job description. So you would feed that in maybe as a suggestion to your taxonomy, and then within Graphologi, you would essentially go through a curation process. So somebody who may be a taxonomist would go through and review it, and then either accept or reject the suggestions, and then deploy that back into the system. And you go through this life cycle continuously. And that's an important part of the process, that taxonomies are living things. It's not a case of you do it, you deploy it, and you forget it, certainly not in most situations. And one other important aspect of all of this is that concepts are born, but concepts also die to some degree. And the term here is deprecation. And this relates back to the idea of IRIs, that if you've deployed an IRI into your system, you don't really want to delete it from the system, because legacy data will refer to it. So the idea of deprecation, essentially making something not usable going forward, is really the way to go. Deletion is not something that you necessarily want to do from your graph in this situation. A graph is a very complex structure, and deletions can be quite hard to manage, to make sure that you don't break existing data. There can be lots of inbound and outbound connections, obviously, from a node. And certainly in this situation, it probably makes more sense to deprecate than to delete. So just to touch on a bit more about the integration options. In Graphologi, you can do a push, which is done via webhook, and essentially you set up an endpoint in Graphologi, and it's in control of the taxonomist when they push that data. And that's an important part, again, of the life cycle, that you would make those changes, and it's up to the taxonomist or some expert to decide, yes, this has been updated and it's ready to be deployed to the production system, and they push the button. Alternatively, of course, your system calls pull data through APIs, and that may have advantages itself, but you do come into the problem of knowing when the data really is ready to pull. So in many situations, a push would be a better way to do it. Okay, so if I switch over to the application itself. So this is what you see when you come to log into Graphologi. Obviously, you would go through a registration process initially to get to this point, but once you log in, you go in and you've got a subscription. So in this instance, I've created a subscription for this demo, and this is what you see. You've got the vocabulary manager and the ontology manager, the dashboard where you manage users, groups, and integrations, and then the account stuff, your usual account bits and pieces. So we'll just go into the ontology manager first, and we just have one project. And that's how Graphologi works. It's all project-based, and permissions work at the project level, so you can control who has access to a project and who can do what in there. And if we go in, we've only got one ontology loaded in this project. You can have multiple ontologies, so if you need to make connections between your ontologies themselves, and that's quite a common thing to do. So we'll just go in, and it's a very simple ontology. We can see here that we've got a few classes. So we've got programming language and a few subclasses of it. So object-oriented programming language, for instance, certification, person. Basically, this is your model in the flesh, so to speak. And then you've got various kinds of properties. You've got object properties, which are relationships between entities. So you saw some of these on the slide about the person. Has certification, has skill, has worked for. And if we look at these, you can see that it's possible on these properties to define domains and ranges. So that what that means is the domain means that the property essentially belongs to things of that class. Now, in OWL, this is done through something called inference, where essentially if you see the property, you can infer that the subject is a person. But Graphologi itself uses it in a slightly different way, more to assign properties to entities, and I'll show you that in a bit. But the principle is the same. And you can have a range, which essentially then means that's the kinds of things that the property can take as values. So in this instance, certifications. So that's a very simple ontology that's for this demo. They can obviously get quite complex and quite large. And we'll just switch over to the vocabulary manager, which is where our taxonomies are. So we've got 3 projects here. We'll go into the MarkLogic demo project. So you can see here we've got quite a few taxonomies set up: business processes, certifications, IT companies, and you can have as many taxonomies in here as you like. Each one is essentially technically a SCOS concept scheme, and obviously everything in it are SCOS concepts. On the right, there are no collections in this example, but essentially we support SCOS collections as well, and they can be ordered and unordered, and they can be very useful as well for grouping stuff together. And we touched on collections slightly in the previous demo. So we'll go into a couple of the examples here, and some of these would potentially be used to do your entity extraction. So programming languages, was one of the examples that we saw, or may come from your entity extraction. So we'll just go into there. And so this is what it looks like in your taxonomy. I mean, this is a very simple taxonomy. There's not much in the way of hierarchy. We've got a couple of examples of C# and more specific versions of C#. But in this instance, I say it's a fairly simple one. They can get very deep and very, very complex. And if we take an example here of Java, for instance, I think the interesting thing here is that we've assigned an additional class to this concept. So not only is it a concept in SCOS terms, it's also an object-oriented programming language. So that gives us more information immediately about what this thing is, and can be very useful for making those semantic queries and those connections if you were looking for things that are object-oriented programming languages, for instance. And if we go back to the project and type in CRM. So one of the things we touched upon was abbreviations and different ways of describing essentially the same concept. So at this point, I'm searching across the entire project, and it's found that CRM, it's recognized customer relationship management as a concept, given that. And this is essentially an example of using those synonyms and those aliases. We can see that CRM is actually an alternative label for customer relationship management. And obviously Graphologi itself is using that information when you do the searches. And if you would have obviously found it if you'd searched for customer relationship management. But again, you can have as many alternative labels as you need to describe an entity. And that may include misspellings as well. Quite often, things like hidden labels are used for misspellings, and hidden labels generally in SCOS terms are never surfaced in a UI. They're there for background processing, so they can be perfect for things that are potentially spelt in slightly different ways, and quite often misspelt as well. So one of the other things we mentioned, if I just go down to programming mistakes. We've really got one here, and we'll just go into it. So this was an example that we had on the slide showing that maybe somebody might be searching for jobs related to the XML stack, but the jobs themselves may contain the actual skills or technical terms such as XML and XSLT. So our taxonomy allows us to essentially create these relationships. Now here we have related matches to MarkLogic, the company, and to XML, and so we've got various technologies, and those related matches could be to anything in the project. And in SCOS terms, related match is used to connect concepts in different taxonomies. There are a set of properties that you generally use if you're making connections within the taxonomy. So in this instance, if we click through to XML, for instance, well, yeah, it takes us through to here, and so we're into the markup languages taxonomy. And here itself, we can see that XML has some narrower concepts, some various markup languages based on XML, and again, some related concepts. XML is obviously related to SGML if you're old enough to remember SGML, and I certainly am. And then there are other related concepts like HTML, which again has its roots in SGML. So those are the kind of connections you can make, and obviously this can feed into query expansion in downstream applications. If you're searching for XML, then you may in this instance be look for documents that contain these technologies such as SVG, XBRL, and so on, and it allows you to do that. So in our slides, we also saw our person, Mary. So this is Mary in the application, and we can see that we've given Mary a class of person, and in a similar way to the programming languages, this potentially allows us to make queries to find things that are people in our knowledge graph. And if we go down, this is where the relationships from the ontology are being used to add additional properties to the concept. So SCOS itself goes to a certain level, but they're very generic relationships, really to do more accurate or more specific relationships. This is where you need to use your ontology to say more specific things about particular concepts. So here we have three properties: has certification, has skill, and has worked for, that we saw from the model and being used here. And as we saw, I think the example was MarkLogic Data Hub Service. You can see there that hopefully you can see that on screen. That's the URL or the IRI that essentially is pinned behind the MarkLogic Data Hub Service. So again, we're making that connection via the IRIs. That's how it's done. So just one more example on this. So if we just go back to CRM. So on our slides, we also mentioned about support for multiple languages, and we had the Dutch example there. And so we can see that here, that we've got two different labels for the same concept, customer relationship in English and the Dutch version, which I'm still not going to say. And again, you can have as many labels as you like in as many languages as you like. Now, one of the important things potentially when you're working in a multi-language setup is the kind of completeness of your data. What you don't really want is gaps potentially. So if, for instance, we look at the statistics for this taxonomy, and obviously it's a very small one, we can see that we've got 3 English labels and 1 Dutch label, and this might well tell a taxonomist that we need to do some more work to bring the Dutch language up to speed with the English labeling. And the question is, well, how do you know which ones are are missing? So Graphologi allows you essentially to switch the view language that you're viewing in. So we're looking at exactly the same data, but in this instance, we're looking at it from a Dutch perspective. So everything you see that's now highlighted orange is telling me that those things do not have Dutch labels. So it immediately shows you that there are potentially gaps. And so as we saw in the statistics, we've got two concepts there that don't have labels in Dutch. So that potentially then allows you to go through, again, your curation process and your governance process of making that more complete if you need to go down that road. So we touched on life cycle governance. And if I go back up to programming languages. So we mentioned about making suggestions. Now in Graphologi, this is at the taxonomy level. You can do this down at the concept level as well, but these examples are essentially at the taxonomy level themselves, or the concept scheme level. So we can see here that we've got a couple of suggestions that have been made. One for essentially to add the label basic. So obviously, but basic is a programming language. It is an oldie, I think it was the first one I worked with many years ago. And so somebody made that suggestion, and anybody essentially who's part of the team working on the project can make suggestions. And then somebody's come along, in this instance, it was me as well, and made a comment. And that discussion could go on. Everybody can participate in the discussion. So you can have a discussion thread to go through the process of discussing whether something should be accepted or rejected. And in this instance, it's been accepted. And we've got another one down here, which as yet hasn't been accepted. Somebody suggested PHP. That's different kinds of suggestions. Some are immediately actionable, things like new concepts, moving or deprecating. And if you push the button, the system will do it for you. So I'll say, okay, yep, we're going to add PHP to the system. I'll say, cool, and add. And then hopefully you can see that coming up to say something's been added, and on the left you can see that PHP has been immediately added into the system. So as we mentioned in that life cycle diagram, yes, maybe PHP has been found to crop up, and we want to add that into our system. And this is essentially one approach to the governance of and thinking, yes, okay, this is how we're going to do it, and how we're going to accept new terms. So if we just go back into let's go back into Java. So we mentioned about deprecation. Actually, we'll go to action script because I've already deprecated this one. So action script, I think, came from Flash, which is now pretty much obsolete. So this is where this concept has been deprecated, and this little button up here essentially allows you to deprecate and undeprecate. And the main difference, if I go back to Java, you can see here everything has got these plus buttons. You can still make changes. When something's deprecated in the system, essentially it becomes almost read-only. There are a couple of things you can do. You can still delete it, obviously, but essentially it becomes a read-only part of the system. So as we mentioned earlier, in that life cycle, once something reaches this state, you'd probably hide it from your UI, but it's still there in the system. But that deprecation information is there, and it has its own special triple. If you can see this on screen, OWL deprecated. So that's actually from the OWL language that we use that property. So we mentioned about deletion to say deletions, yes, you can do it, maybe not the right way for a lot of situations. And then just to finish off, we go back to the project page. So we mentioned about integration. So, okay, I've done my curation, I'm ready to send my data across, or am I ready to send my data across? So if I click the synchronization button, I've set up an integration in the background, and that's done through the dashboard. But if I click this button, essentially then I can select from one or more integrations. And obviously you may want to send this data to more than one system, or to a development platform and a production platform, so you can set up multiple integrations if you need to do that. So I'll select this one, and then the system takes a look and says, right, okay, what's changed since you last did this integration? And we can see that a couple of the taxonomies have changed. IT companies has changed, and programming languages have changed. Obviously, we just added a programming language, so that would be included, and it gives you a count of the number of things that have changed since you last ran it. So it's then within your control, essentially, it's to what to send into your system, and by default everything is ticked, but it's within the taxonomist's control as to what they send, and you essentially would push the button and off it goes down to the endpoint at the other end. So that then kind of completes the process and the life cycle, and that's kind of more or less it. So yes, take your taxonomy, curate it, put it in, go through that life cycle, and then over to Drew for the next stage, I think.